We are starting off the track for MHS, Modular Hardware System. This will be going throughout the afternoon and closing off OCP Global Summit. And first off, we're going to give an overview of MHS and then get into the high level of updates of what we've been up to this year, and then subsequently we'll be getting into the details. I am Shawn Dube. I am one of the co-leads here with...
My name is Brian Aspnes. I'm with Intel. And not here, but definitely contributed to these slides as Aurelio, also from Intel.
And then also John Lewis, also of Dell, and Aurelio and John have been the lead for the power side, MCRPS, and so we're doing a combo MHS overview and CRPS, and then leading into the other parts as other official sessions.
So the biggest change this year is that MHS has grown significantly. We actually have a new sub-project name under server called MHS. The noticeably absent is the DC. However, the way we've structured it is we now have DC MHS, or Data Center Modular Hardware System, as a work stream under the MHS sub-project. That has its own companies operating under its own CLA and their own monthly meetings. The new one this year is Edge MHS. So again, a different set of companies participating under that CLA, reporting up to MHS in our monthly meeting. And then our DCSCM workstream leads will talk about this more later on. But DCSCM used to exist in the hardware management project, and we've recently moved them over under the MHS umbrella, since it's all very closely tied. The vision here is that these are not, although they're shown as independent work streams with independent companies, there's heavy reuse between all of these, right? So with DCSCM as an example, one of the things we'll be talking about is a new SCM that we're working on. We want to incorporate that into both DC MHS and Edge MHS. And so on our, please visit our new website, check it out. We do have 3 different wikis for each of these. So you'll find specs and designs for each of them on independent wikis. Do you want to add anything, Shawn?
You covered it. So it is a big team, different focuses, whether it's the data center, edge, or manageability, but ultimately we all work together, and it's all an overall one large project under MHS. Okay? Okay, so just a quick recap on DCMHS. This is the 3rd year at OCP Global Summit that we've had this track, and this was one of the very first slides that we had amongst the companies that came together to get DCMHS going. The approach that we wanted to take, or what the problems we wanted to solve, was to allow the silicon providers to solve or to innovate however they needed to, but at the same time allow platforms to continue to innovate, and to increase efficiencies, to increase speed, having the commonality of the building blocks within the servers that the silicon providers could understand exactly. If I can fit within this form factor, then I know that my platform providers can take my innovation. Likewise, from the platform side, by having a common form factor, common interfaces, that we knew that whatever the CPU or the silicon providers produced, that we were able to take what they have, put it into our platform, and get it to customers.
So this here is a kind of a visual picture that we like to use, where we try to break up the work here. So we have today on the wiki, there's 8 different work streams under MHS, right? Each of the work streams is focused on a particular part of the problem. I'll kind of go around this picture to illustrate the point, but the idea is these work streams, although they do talk to each other, are mostly working on independent specifications focused on a particular topic. So MPIC is our what we call platform infrastructure connectivity. Think of this as how do things like the host processor module and the CRPS interact with one another? How do they host processor module and the DCSM interact with each other? So you need to define that connectivity in a system between these blocks. So that's the MPIC. New this year is support for 48 volts. So in the past, MPIC specification was primarily focused on 12 volt. This year we're rolling in 48 volt that will eventually be bringing into the host processor modules. Because of Global Summit, I haven't actually posted the latest specification for 48 volt, but look for that by the end of this week. I'm going to skip the design specs. For high speed, this is the interconnection between the host processor modules, or the HPMs as we call it, and the peripherals. So we work very closely with standards bodies like JEDEC and PCI SIG to develop both the high-speed part of the connectivity between the peripherals and the HPM, but also the low speed, right? So one of the things that we've developed is being able to discover what is attached to your HPM. Is it storage? Is it a GPU? And we bake that into our XIO and PESTI specifications on how to do that. Additionally, if you're familiar with the latest PCI SIG specs, you can find this same information aligned to their internal cable specs. Plug and play is our newest work stream. I think we have a deep dive on this one. This is really how we say we go into the hardware and the firmware and how things should be discovered and configured and communicate at a deeper level than just, hey, you have this connector. And then we'll be talking about this next, but we have currently three different host processor specifications, full width DINO and SDINO, and we'll cover this the next half hour on the differences between those. And then finally, the design specs. What these are is most of these on this page are base specifications. So think of them like a toolbox of how you solve problems. The design specs sort of fine-tune that and give you more information on how to do the implementation. Do you want to add anything?
No, that covers it. One of the things I will just add, it's really exciting with the SDINO specs that we have. The next slide, we're going to be talking about AI. SDINO is a set of form factors that are going to be especially important for that. And then the plug and play. The ultimate goal it's going to be a hard problem, but our ultimate goal is eventually get to the point where you can have a brand new HPM that is completely new to a platform, take it, put it into a platform, the firmware is able to discover everything about it and get up and operational. That is an aspirational long-term goal, but that's ultimately what we want to achieve with plug and play capability. And that is getting to a very open ecosystem with how silicon and platforms work together. Okay, so AI, it's big. So first off, there is no one AI architecture. So when we think about what is necessary for AI platforms, there's different ways of solving the problem, whether it's one CPU with a whole bunch of GPUs, or it's tightly integrated CPUs and GPUs, or when we get into the interconnect, how do the GPUs and the systems interconnect together? Are all the connectivity points up to common switches? Do the GPU devices talk to each other, but then they're still switching to help with scaling out further? There's many different answers. And that's approach with DC MHS that we believe that we've come up with the right solution that allows for this kind of flexibility. So from a readiness point already, we have a collection of different HPM form factors that are used today with different AI solutions. We have put a lot of effort into future-proofing the HPMs, that they'll handle multiple generations of silicon to come. We have been purposely permissive on certain things that would be thought of as requirements. On I/O, we don't prescribe exactly which connector you have to use. We give recommendations. We understand that there's going to be future connectors for handling future I/O. Likewise, the amount of I/O, or exactly where it needs to be, we do have permissive ways of approaching this that allow for HBMs to be optimized for different applications. So we have enablement for Open Rack, form factors that are especially optimized to take full advantage of Open Rack and high power solutions. The 48-volt supplies that Brian talked to, both from a power standpoint as well as how HPMs are powered, or the peripheral set. That's part of the architecture. But there's still more that we can do, making AI better through DCMHS. So first off, one of the areas that we want to improve is with the DCSCM. It doesn't always go in the right place within a system. We are working on a 1U form factor that can be embedded inside the system. We'll talk more about that later during our DCSCM session. Multiple HPM management. This is dealing with multiple nodes that may be within a chassis. That is another effort that we have in flight that we're investing in. Scalable HPMs. This is effectively the SDNO solution. We think we've got a really good answer, but there's probably something more that we can do in the future. That's why we're here at Global Summit, to discuss these things with everything, to understand how we can do better. And then number 4 is dealing with interconnects. So whether it's NVLink or UA Link or something else, we want to figure out how to interconnect all of these nodes together in an open fashion that we can apply our building blocks for the efficiency and for the value of customers. And then last, number 5, we need help. What are the other ideas? What are the other problems that we need to solve? This is the opportunity for feedback to work together.
So really the call to action here is that what we're trying to describe is that our vision of MHS is that it's future-proofed. And the idea is bringing a mix of silicon and platforms. It is a choice to build and innovate on these open standards and hardware versus building on yourself. And we have a great panel coming up later where we have some hardware providers. I encourage you to attend. And then the AI that Shawn just talked about, right? That is the new hard problem. Our vision is that that's open, it's modular. You know, we want to work with MGX as well to build upon this. I've given the project website as well as the mailing list, so you can get a hold of us at any time. So, Shawn, do you want to take?
Yeah, coming up next, so getting into power with MCRPS, John is going to join us on stage. And then following that, we have a collection of other sessions to go into details of the different parts of DCMHS as well as Edge MHS and DCSCM.
All right, thanks, Shawn and Brian. And I'm John Lewis with Dell, and I am the co-lead for the MCRPS, the Common Redundant Power Supply for DCMHS. Unfortunately, Aurelio wasn't able to be here, so I am here in his stead. So the workstream status. So we started back in September of 22. There's been a large number of updates, and I'm happy to to report that if you go out onto the floor, the expo hall, you'll see quite a number of MCRPS power supplies in different various configurations, which is quite a testament to the short time we've had to go from nothing to standards. We just released our 1.05 specification, and the good news is there's not much left on the to-do list. So hopefully we can be stable for a little while, and everybody can go build this and then deploy it. So what's happened? Well, we've had a bunch of design specifications. As Brian mentioned earlier, we have the base specification for MCRPS, but then we've been adding in design specifications specifically for MCRPS. So we have the ones there. I'm not going to go into all of the details, but both widths, the 73.5 and the 60 millimeter, all at 185. There haven't been any design specifications for the 265 millimeter depth. So that's something that probably should happen given AI's thirst for power. And we've had several major updates, including the ITHD for multiple input voltages, acoustic limits at 100% loading. You can read the rest there. We did just recently add in the Anderson 277 volt input connector, which gives us, again, additional power at the input, AC power. And then it's great to announce that we have a standard test fixture that's available for purchase. So again, as part of the develop and then validate, we have a common validation method for MCRPS so that it helps with the interoperability from power supplies and system vendors. And then a call to action. So right now, we don't have much left to do on the to-do list. We think that the spec is in a really good space. We are looking for what's coming up next. So if you have any ideas, please attend the working group meeting. It's every Tuesday. The project website's there, as well as the mailing list, and myself and Aurelio's email addresses. So thank you very much.
Okay. And we have a couple minutes if anybody would like to come to the mic for a question. Okay, and then we'll have, I guess, a minute or two break, and then we'll get into the details of the SDNO spec. Thank you.
Thank you.